Hello, everybody, and welcome to our session on Jupyter and Jupyter Binder. I'm not going to talk an awful lot about Jupyter Notebooks in general, except just to go through and show you what they are and what they're useful for. For the most part, people do tend to already know. If they need to know what Jupyter is, then they probably already know about it. But I'm gonna get a feel for the audience. Oh, all right, so I am very curious what kind of people we got in here. I know we've got 20 some odd people. Go ahead and close the pool. And we got about 2/3 of the people have participated. Actually, about half the people participated in the poll, and some people put it in the chat. That's great. Thank you to whoever said a planet, because I put that in there for fun times. All right. All right, well, that is great. Good, that helps us just get a feel for who's going to be here. And as I did mention in this morning's talk, if you're here to get a feel for it, because maybe you're an instructional designer or a ZTC coordinator and you want to get some knowledge to bring home to your campus, stick around for the first little bit while me and Carl give some showcases of how things could work. But if you wanted to catch the second one of Heather's talks on project management ideas and how she's used project management on her campus, then feel free to leave at the halfway point. We won't be offended, but we wanted to make sure that people made the best use of their time. So great. I'm going to have a couple introductions just to remind people why we're doing what we're doing. Our goal is, of course, to replace for-profit publishers as much as possible and to create an ecosystem where everything can work together. So we do have content, but we want to make sure that we're also keeping up with the technology that needs to be available to the classes that need more rigorous technology available to them. Computer science, data science, anyone who's using any sort of calculation on with R for statistics, any of those things, we want to be able to make sure that we have everything that we need to make sure that your classes can go and be completely zero cost for your students. For assessment, and then engagement with students, there are really three things that require student logins at LibreTexts. That's Adapt, the Forge, which you've heard a lot about yesterday and earlier today at Sarah's talk. And this is to talk about the Jupyter, which is the other student engagement tool that we have for helping faculty to do assessment. I talked a lot about Jupyter as an embedded thing, so I'm just going to show this real quick. This is what our talk is going to be mostly about, is using Binder to increase engagement with students. So if you have some text in your textbook, you can embed a bunch of little blocks of what we call Jupyter Binder code. And in these code blocks, students can run the code and they can also change it. So an example here is have them interact with, this is how you can, in R, which may be a language that you're using for your lab or for other statistics that you might use in your class. And this is how you would use that. And you could even encourage them to run some exercise where they will change that number of breaks so that they can get a different histogram and see how histograms change as you do that. So that's kind of the embedded part of Jupyter. And I'm going to real briefly touch on if you go to Jupyter itself, this is a Jupyter Hub implementation that we host, but we didn't invent it. There are Jupyter hubs all over the place. It's an open source project that you can run on campus and elsewhere. The nice thing about our Jupyter Hub is you log in with your Libre One account, and students can log in with their own account as well. and then we can run any of these different kernels. So if you're interested in running your own notebook for code and having students run it, and you're able to be as an instructor to go in and take a look at it or give them sort of templates, there's a bunch of documentation and some demo videos that are there. As I've mentioned before, if you know that kind of thing, then you probably have already heard of Jupyter. If you've heard of Jupyter, you probably will not be helped by me trying to explain it to you any more than that. But what I really want to do today is, and why I invited Carl, is to see how we can use Jupyter to engage students. So tomorrow we're going to talk about ancillary materials and how you can use LibreTexts to store data files. What we're going to talk a lot about tomorrow is PowerPoint slides or images or other things that you might want to share with your students, or answer keys that you might want to share with other instructors. But one thing you'll use in the data sciences area, any field that uses data sets, is data files. So inside of the conductor, you can host let's say a folder that's called data, and you can share that publicly so that you can use it anywhere. And so that if somebody were to go to this book on the Commons, they would see this is our book, Visual Statistics Using R. Here are some assets. Here is the data folder, and here's the file that's in that data folder. So you can also have data sets that you are publishing alongside of your textbook so that students can interact with the same data sets that are being used to either generate images or, as we'll show you, interactive code that people can use. So that's one aspect of the data set, the answer materials that you'll see tomorrow. So I'm going to give an example of this. This is one of my favorite books to use because R is used an awful lot. If you've heard of S is the kind of the data, the statistics program that's used quite often, but it's very expensive. R is the open source version of that. A lot of biology faculty will use like SPSS, which is a very expensive for-profit statistics set. R is used more commonly if people are wanting to save money. But here is an example of doing basic t-tests. So I'm going to refresh this page. And what this person has done is written a whole statistics book where it includes code that can be run. And it looks kind of like a block that would have an exercise or a video or a sample problem. So it looks very similar to anything that you'd see. But it's got a table here that you can pull some data. So this is from an old data set. So I'm actually going to pull that link. So if you are at this page here, let me actually go to this page. If you're here and you've got a file that is publicly visible on the Commons, and this is true for anything, an audio file, a image file that you have, you can get a permanent link that you can use anywhere. So if you wanted to link in your textbook to some data file, instead of putting it in a Google Doc folder somewhere or Google Drive or putting it in some other shared database, you can put it right into your Conductor project so that you can paste that link into, let's say this, in this case, we're talking about using this data set that's shared alongside this. And then Carl's going to go through the little addendum that you have to use if you're going to directly use it in code, but I'm just going to type it there and so you can show it to you. If I click on run, it says that our session is ready to run, and you can see it showed me the data set that it read from that database. And then it looks like I might have messed up my normality set. But you can run all the different codes there. I don't know if I messed up where. Integer normality. Oh, that's okay. So you can go through and actually use these different data sets in there, which I'm going to go back and use one of the other pages there. I don't know why this one doesn't want to run.
Justin, if you do a page reset, you will restore to what it was previously.
Say again?
If you use a page reset, it will restore what was there previously.
Oh, I'll try that in a second. This one happens to be running, so I'm just going to run this one here real quick. So this one here, I ran that. This one actually runs a box plot. It drew this box plot. If I were to change the data set that's there, have a student mess around with it, they run it again, they get a different box plot. So you can have people have images that you run, and then you can also have them engage in different ones like running that histogram. This is an example I use a lot. This one has 20 breaks, or I can make it have 2 breaks. 1, 2. So in terms of having students engage with data, and as opposed to just simply looking at data, this can be a really great tool, and for teaching, obviously for teaching very basic statistics, it can be great. I actually use stem and leaf plots all the time. I don't know if you do, Carl. But I always use stem and leaf plots. This is how I always wrote on the chalkboard what the grade distribution was for my students on an exam. I would write 10 down here, and it'd be 100, and then all the way down to however many were. That way it'd be super quick. So this is just a quick example of how you can do extremely simple statistics that you might use in a lot of different classes. Like I mentioned earlier today, I know a lot of my communications faculty that I've worked with have done like word analytics and common words that are being used in this document versus that document, or data mining across Twitter feeds or X feeds. And all of that requires very simple but basic data analysis. And this gives them a very low entry into getting into coding without needing to learn how to run code or compile code in any sort of way. So I'm really excited about it. And I think Carl has some other really nice examples for larger data sets than 5 or 6. Oh, where is... Oh, Carl, I'm going to move. Wait, that's my stage. All right, are you able to share your screen, Carl? Any questions on some of that just before we move on to a different topic? Oh, I got some question and answer questions. Andrea, for truth tables, proof, and logic, definitely any of those are very relevant in most programming language can do proofs and can do logic. If you want to teach them a basic coding language, the binder uses the Jupyter Hub, and Jupyter is actually a set of kernels that can be run, which is different coding languages. Jupyter actually stands for, dang, what does it stand for again? It is Python is the PY, the R on the end is R. Julia, that's what the other one is. So Julia is the JU. So it's a different one to different things there. So if there's a bunch of different kernels, if you go take a look at our documentation, it'll tell which coding languages you can do. And then you can have them do basic coding for Boolean algebra, which is logic, and that can be helpful. In terms of proofs, I'm not sure if it can be coded, then it can be done. I'll say it that way. And then the other question real quick is for Abby. There's no cost to this because we're not saving any student data. There's nothing in the Jupyter Binder that has any saved student data, so you don't get to see what students were doing when they were on your web page, on your textbook, and manipulating those practices. If you want to actually use Jupyter as the service and make a notebook where students engage and write code, then that has the same kind of fee structure that the Forge and Adapt have, which is $15 flat rate. So as many classes that want to use it can use it. There is, if you're a LibreNet campus, then it is bundled together. There's just $15 one time, and that covers the cost for Adapt, Forge, and Jupyter, all of them at the same time. The one thing I will note is the Jupyter gradebook doesn't really have a gradebook. Does not really have a gradebook. We're hoping to build it a little bit better. Does anyone here want to guess what platform we want to merge the Jupyter Notebook platform with that already exists on our LibreVerse? Delmar, you can't answer. What do you think would be really great to watch students do while they're writing code? Yes. So Abby is perfectly right. We actually want to integrate the gradebook in Jupyter through the Forge so that you can actually see how students are editing code when they're working on it and how they're modifying it, to really, again, to focus your pedagogy more on the process of evaluating code and writing code as opposed to just the final code that they get. Because anyone who teaches anything to do with code knows you can ask Claude to write any program you want. And they're gonna just paste it right in there. So there's some growing that we're gonna be doing there. And if Delmar wants at the end of this to pop up on stage and talk about some of those future things, then I will and have him do that. But in the meantime, let me see if there's one other question. Oh yeah, so Abby, you answered as a question. Yep, so Allison as well. It'll be, the Forge will get, things will go through that way. Awesome, okay, I think we're all caught up. Are you gonna share your screen now?
I can, sure, if you're
awesome.
Ready for me.
I'm ready for you. I think we're all excited.
All right, so so hopefully you now can, well, not yet.
It's coming.
So you can now see my screen?
Yes.
Okay. So basically, just to start with, thanks, Justin, for inviting me to give this presentation. I'm really excited about being able to encode Jupyter type code or Python type code within a LibreTexts document. I started out using Jupyter Notebooks because I could integrate text along with the programs, but I found that there were some limitations with the Jupyter Notebook that just didn't have the editing capability that you'd like to have with a text type document. So the advantage now of being able to incorporate text or with the code, I think is a significant advantage. And really now with the option of making it interactive so the students can participate, they get more of an interactive textbook than they would just by reading either an online book or a in-print book. So the first thing I'd like to talk about 3 different aspects of using the Binder application. I'm not going to go into how to build Binder. I think we have a session this afternoon, a breakout session, when we can go more into detail, but it's not difficult to do, so we'll do that this afternoon. What I would like to do, though, is talk about some options, and one option that you would always like to be able to use is use external data, and Justin just talked a little bit about that, and I just want to follow up on that. So basically, what you do is you go to your project, and as Justin pointed out, you have a ability with assets to add the data. In this case, I have a folder called data. Okay, and actually that's the file called data. I have a file called data, and then over here I have the ability to acquire a permanent link to that, which I can copy, and then go back to the code and where I want to actually read it into to an application, I can put the code or the URL in there, but I need to append this. It's not highlighting very well. This question mark direct equal true. And basically, without going into a lot of detail, that just prevents LibreTexts from modifying the document that you're trying to read in to make it more visible on a web browser. So it just reads it as raw data, basically. So when that happens, then I can then run this code, and this will just present a histogram. Of course, this turns out to be, I had created a data file with 500 data points. I set it up to have a mean of 2 and a standard deviation of 1.5, and you can see it this is what the estimate is from that set of data points, and then the histogram that was created. So the next feature that I wanted to talk about was that frequently, at least in Python and probably as well in R, you have packages or libraries that are not installed as part of the original distribution that's on the Binder server that LibreTexts is running. So in this case, what I wanted to use was a package called scikit learn. Okay, and that's the package to pick up the library sklearn. So that's a machine learning package, and that's not typically installed. Well, it's not installed with this Binder distribution. Okay. However, I can install it using a pip install command, and to do so, I need to precede that with the operator that actually runs this in the operating system or terminal mode. Okay, and so I just do a what's referred to as a bang operator or exclamation mark pip install the scikit-learn. Okay, and once I do that, what you can see. Oh, and there's the other way of doing it is to use the conda install. So conda is actually installed here as well. However, conda takes a much longer time to load than the pip install. So if the application doesn't require conda, it's better to go ahead and use the pip install. So I can run this and show you what happens. So it's first of all going to go out, find the application, install it, and then run it. So as you can see, it's pretty fast. So it went actually out, downloaded the package, installed it, and then ran the application. In this case, I'm just doing a linear regression. Okay. And the last type of application I wanted to show was how to actually use this in kind of a formative assessment mode. So one can do this by of course using adapt, but there's a block that you can install within the LibreTexts document called an exercise block. Okay, within the exercise block, you create a question, and then you can provide an answer. So in this case, what I did was I utilized the exercise block, and within the question part of the exercise block, I installed the Binder application. And within the Binder application, I've included some initial code, and the student then needs to add some code to, first of all, find the sum of two forces, okay, in 2 dimensions, and display the results in terms of the resulting sum, the total of the sum of those two forces, in both rectangular form as well as polar form. Okay. And so I've given them the answer here of what they should get. And I also say, okay, we'll also find the reaction force. So if you have a equal and opposite force, according to Newton, the reaction force should be the negative of the applied force. And so here's the answer that they should get. Okay. And so the student then has the ability to go through. Let me see if I can increase this a bit so you can see it a little better. Hopefully that is a little easier to see now. So the student then could go in and add their code here, okay? But I can also apply a solution or display a solution. So if you go down here, the solution is shown here, okay? So this is the code that they, could enter. I mean, there are several different ways of doing this. The first section here is a function to convert from rectangular to polar coordinate system. Okay, and I created a function because I'm going to use it twice. Okay, and then simply finding the sum of the two forces here, converting it from rectangular to polar form here to find the magnitude and the angle, displaying the results, and then finding the reaction force, which is just the negative of the total. So just to show that this works, I'm just do a copy and paste back up here in the code. Okay. Okay. So now this, as you probably are aware, in Python, formatting is critical. That is, when I define a function, I have to include either a tab or set number of spaces between the instructions within that function before I end the function. Okay. So that's critical in the way that this is added to the solution. I'll show you that in just a minute. But just to show that this runs properly, go ahead and run it. And you can see that the results were what the expected answer should be. Okay. Okay. Now here's the issue with this. This is when you do a exercise like this, the option to cut and paste the solution does not use what's referred to as a code block within HTML. So to utilize this, you actually have to edit it. Let me scroll out just a bit so I can show that. Okay. Okay, so I can edit this section. All right. So this is what it would look like in the editor mode. So this is where the solution is displayed. But if you just simply copied this from, say, an external IDE development tool for Python, for example, and pasted it in here, what would happen is you would end up with the code added as an HTML set of paragraphs. So each line would be its own paragraph. So that's not appropriate for code. So what you have to do is go into HTML mode. So if you can see my cursor up in the top right here, and if you click on HTML mode, I'm now displaying this in HTML mode. And so what you do is between this DD and /DD, okay, you install this, you install your function here or your code here. So there's a, maybe hard to see with the highlighting, so let me stop highlighting. There's a tag that you enter, followed by a code tag. At the end of you need a /code tag and a /pre tag. So if you do that, then going back to the unedited mode, you can see that the code actually appears as it should in a standard Python description. Okay. Let me see. If there are any questions. Justin, are you still here?
I am still here. I just changed the layout so your screen would be bigger.
Okay.
If anyone does have a question, feel free to raise your hand if you'd like. All right. I'm going to give you the mic, Abby.
So just to clarify, the code tag makes it so that the solution appears in like standard coding format for the students to see it. Is that?
That's correct. Yeah. If you didn't do that, if you just did a cut and paste into the solution block for the exercise, then what will happen is HTML will encode each line as its own paragraph. And so it'll eliminate the formatting that's required for Python. So if you want to include code as the solution, and I'll also, by the way, I changed that from answer because it defaults to answer instead of solution, but I want to make it solution. If you want it to appear as a code segment, then you have to specify within HTML that it's a code block. And the way you do that, and I kind of indicate this down here below this. Oh, by the way, this is in a book that I'm creating, and we haven't actually published it yet, but we will go ahead and publish it, so it'll provide all this information for you. But basically what you have to do is enclose it in this pre/code tags, and then it'll appear as a code block. It won't be formatted with individual statements as their own paragraph.
Also, to follow up with that, if you've been to one of our publishing remixing sessions about how to remix things, this book will be published. I asked Carl if we could publish it up there so that people this afternoon could remix these pages right into their own book so they can get a copy of it and see how Carl did this. So if you want to attend or send anybody to that session this afternoon, you're going to be able to get a copy of his pages and actually play around with them. Great. Any other questions?
So if we have time, I did have one other thing I wanted to show.
We do have time, and I was like going to say, don't you have some climate data that I wanted to see? The modeling?
Yeah, so let me. So this is actually from one of the books that I use for one of my courses, digital signal processing course. And what I wanted to do is kind of introduce this to the students. And one of the things that we will do in digital signal processing is learn how to do spectral analysis. And so what I found was a data set of sunspot data that goes back to 1749, so that's 277 years ago, where they're recording sunspots on a monthly basis. In the 1800s, they started recording them on a daily basis, but I wanted to go back to the beginning. I guess if they were recording data back in Stonehenge, we could go back that far, but right now we only have data back to 1749. And as you probably know, sunspots are cyclic. And if you look at the variation in the sunspot data, this is kind of what it looks like. Okay. So back to 1749 up to present time. So on a monthly basis, actually on a daily basis, this is updated. I'm using just the monthly accumulated results. And what I'd like to do is show the students how to obtain a spectral analysis to find the spectral content of this data. And so what I did was create a little set of Binder code or Python within Binder here to read the data. So the data is actually installed in a assets folder. Okay. And, I can also read it directly online, but I chose to download it, install it on the LibreTexts network. And if I run this, what we'll get is, first of all, it just displays the first 5 data points and the last 5 data points. And so you can see that there are 3,329 months since the beginning of when it was recorded. And this is up through June. Okay. And so there are a couple of features that I can have the students work on. One is implementing a smoothing filter, which is basically what's referred to as a low-pass filter. So they can design a low-pass filter and then display it along with the original data. So the red here is the low-pass filtered result, and the blue is the raw monthly data. And then below it is the power spectral density or spectral content of the data. And there are sort of 3 prominent peaks, one here at 0.0117 cycles per year, which turns out to be a period of 85 plus years. And then the more prominent peak occurs at 10.6 years, 6-7 years. And actually that's a little off from the 11-year cycle. And the reason for that is that this is detecting peaks. And if I zoom in, see if I can, you may be able to see a little noise point here on the peak that occurs slightly beyond the actual peak of that period. Okay, and so it's estimating a time period of 10.6 years instead of 11 years. And that illustrates one of the issues with just finding the peaks to estimate what the period is. One should use kind of a center of mass approach for this peak to find the actual peak. Okay. But the advantage, of course, is that students can go in and make changes to the code. So, for example, so right now the filter that's being used is what's referred to as an FIR filter of length 12. So that's, 12, that's 12, it corresponds to a year. Okay. So if I wanted to make it 2 years long or 24 months long, I could change that to 24. And also that's a cutoff frequency of 0.4. I could change that to say 0.2, okay, and rerun this. And then if you go down here, then it may not be that obvious, but basically I'm now cutting off at 0.2, which is where my cursor is here on frequency and cycles per year. And so I've got a bit of a smoother estimate for that periodic activity. And so most of you know that the sunspots vary periodically. I don't know that you know the reason for that. Basically, it's the magnetic, well, it's the activity within the sun, of course, that causes that. But actually, it's the magnetic pole of the sun that's shifting every 11 years. So it switches between a north pole and a south pole magnetically every 11 years. And of course, that's the peaks that are associated with more of the activity, like the coronal mass ejection activity that occurs with the peaks, and with the quiet periods or down at the area where there are very few sunspots. Okay. So that's just one application, and it's a fairly extensive application that can be embedded within a book, and very easy to do with Binder to do that. Any
Awesome.
questions?
As I said in the chat, I just find it so impressive that all of this could be done in just embedded in a textbook. So you could actually have this be the way you learn this material, as opposed to just an exercise you do outside of that reading portion.
Right. Yeah. I mean, that's the advantage of Binder, is it makes the book interactive. And I think by making books interactive, you engage the student. And I think that's one of the issues that we have right now, that I have at least, is first of all, just getting the students to read the book, but also engage with the material. And by making the books interactive, I think it facilitates that process.
I mean, there's even ways, to be honest, where you could have code that has to be run on your web page, on your book, to get an answer. And that answer could even be a reading check question in your homework to say, hey, I'll know if you read this page if you actually went and ran this Jupyter Binder chunk,
Right.
as opposed to.
And you could embed adapt question that could be summative.
Yep.
To actually track that.
Yeah, exactly. I hadn't even thought about that. But yes, for anyone who wasn't aware, you can also embed adapt homework questions that are graded alongside Jupyter Binder. So you could have formative things that are exercises. You could have Jupyter Notebooks where they run full sets of code that maybe incorporate multiple exercises. And you can have graded assessment questions as well.
Yep.
Great. Any other questions from the people? You can either raise your hand or drop them in the chat.
So Justin, as I recall, we do have a session this afternoon, a breakout session.
There is only one more Jupyter session, and that is in about it's at 5 o'clock my time, which would be 2 o'clock Pacific. And that will be again with me and Carl, although it will be a lot of it'll be more of the hands-on, how do you actually go about doing this yourself? So implementing some of the things that you saw today in your own book, uploading your own data sets, and then all of that. So sure, I will give an example. So the page that I did was in the statistics library. And then we're going to review the book that Carl is showing right now in the next couple hours and get that published and then ready for people to remix and use there. How to do this in detail. Definitely, I think the most detailed description of this is actually the little bitty book that Carl put together, but our construction guide does have some examples of Jupyter Notebook as well, and Jupyter Binder. And I will send along the link to that page. Advanced. So this section and subsections of our construction guide does go over that. So that hopefully addresses your question, Abby and Neil. And we have just about 10 minutes or so. I'm going to pop up the end of session survey. Carl, what's been the general feedback from your students on being able to do these sort of interactive exercises as opposed to running off to different platforms?
I think to most extent they enjoy it. I haven't formally assessed that. I need to do that. But
at least they didn't come after you with torches and pitchforks?
Yeah. So, not yet.
Well, you've been doing this for a while, right? This is not semester 1 of using Jupyter Binder.
No, not at all. In fact, and we're also incorporating this in a book that we're using to teach modeling and analysis. And we're using Python now for teaching modeling and analysis. And so I created a book last summer that we're, a LibreTexts book last summer that has built-in exercises similar to this that we're using for that course. And we have gotten student feedback from that, and for the most part, it's very positive.